Yeah, so I think we can go ahead and get started. We have a nice little group here. Thanks for coming, everybody. So today we're going to be talking about the MicroPULSE, which is one of the newest products at Formulatrix. It's kind of our first entry into the filtration market. So today I'm going to be overviewing for you kind of the, why we attacked this project, how it's used, kind of some applications of it, and then what people have been thinking so far. This is one of the newest products at Formulatrix. So first, kind of get started. Who here has seen or worked with a spin concentrator before? Probably quite a few. Even if you haven't, you probably have a friend that has. These are a great invention. They have completely revolutionized a lot of biologics processing. However, nobody enjoys working with them. I think that's a pretty common theme. And so a few years ago, we asked ourselves, how can we concentrate and diafiltrate samples at the R&D level in a better way? And so when we look at concentration and diafiltration, there's kind of two main ways of going about that. We have dead-end filtration, and this is when we're applying some sort of pressure, whether it's air pressure or gravity, to our sample, and we're forcing it through a membrane. This is akin to a spin filter. And then we have tangential flow filtration, and this has long been a part of industry. This is when we're flowing our sample rapidly across the top of a membrane, and that high-speed flow is scrubbing that membrane surface, keeping it clean, and allowing you to concentrate very rapidly. And so we look at how these are typically applied in the field. We have our spin columns with dead end. These have typically a 15 milliliter max volume, and they go down from there. Very little process control. So these are usually done by eye. You load your sample in by eye, you monitor it by eye, you diafiltrate it by eye, and you can dry it out by eye too. And that creates a really high personnel expense. So people might be using these columns one day a week for 4 to 6 hours every day that they go to use them. On the other hand, we have an industrial TFF and traditional TFF, which is typically kind of a larger contraption. This is built by a process engineer in-house, and this has a larger holdup volume. So that necessitates kind of 1 liter minimum of sample volume typically. The smallest TFFs on the market have 10 milliliter dead volume, and that kind of forces out a lot of low-scale R&D. And this also has a high barrier to entry. So these are expensive systems. They require process engineers. They're hard to set up, and they're hard to optimize. And so the Pulse is kind of aimed at sitting right in the middle and applying all the benefits of TFF back to the volume and user-friendliness of these spin columns that anyone can just pick up and use. And so that's the MicroPULSE. And so we're able to concentrate samples from 100 milliliters max down to 0.5 milliliters final volume. We can buffer exchange automatically up to 250 milliliters of buffer. We can also automate the holdup recovery. So we can recover your sample with air. We can recover your sample by rinsing buffer and recirculating it across that membrane. And the cool thing about the Pulse is we actually have the lowest TFF holdup volume on the market at just 650 microliters. We can also do stepwise process control. So all the same process parameters and control you might have in industrial TFF, you also have with the Pulse. It's just miniaturized down to kind of 1/10 that scale. So we have a lot of customers coming to us trying to use the Pulse to scale up their TFF process up to their industrial system, or perhaps they already have an industrial process, they're launching a new drug, and they want to scale back down and use this as kind of their intermediate solution. Either way, the scaling is there. And lastly, we have this very intuitive software that both allows you to control and remotely monitor the Pulse. So if you've used any of our other products, you know we're kind of built around user-friendly software, right out of the box use, and I think the Pulse is about as intuitive as it gets. So let's look at how this actually works. So when we look at our chip, kind of the meat and potatoes of the Pulse is this filter chip in the middle, and this is your entire fluid path, and this is also a consumable. So we have a diaphragm pump that will aspirate your sample and then inject that at high flow across this serpentine membrane channel. And what's going to happen is the same thing you saw in that tangential flow diagram. We're flowing your large molecules at high flow over the surface of these membranes. The salts and smaller molecules are permeating through. And now we can also do buffer exchange. You can load in buffer in one of your tubes, and it'll aspirate that buffer into that same diaphragm pump and dispense that into your sample. So you don't need to stop your centrifuge, take out your tube, top it up with buffer. You can just automate that whole process with the Pulse. So let's look at kind of one of our first user stories of someone that really had a lot of success with this. So they had a protein, 60 kilodaltons, that they were trying to first concentrate from 50 milliliters down to 2 milliliters. So that meant with an Amicon tube, they were splitting that into basically 4.5 different spin concentrators. They were then concentrating it down, removing all those tubes, topping them up with buffer, concentrating them again, and they were running that process 7 to 10 times. And that was taking up their entire day. At the end, they're getting pretty good recovery, though. When we look at the Pulse, when they adopted that, they load in their consumables into the system. They run a cleaning protocol. They can then just insert their samples and press run. And that whole setup time is about 10 minutes. And when we look at the touch time comparison of the two, they had 6 hours and 15 minutes to process their sample with centrifugal filters, and that's hands-on scientist time at the bench. With the Pulse, it was 25 minutes of touch time. So this is a big deal. We're not selling faster concentration. We're not selling better concentration. We're selling more of your scientist's time or more of your time to actually do the work you want to be doing and not just staring at a centrifuge all day. And that's kind of the biggest value add with the Pulse. So I want to just show you how we're able to reduce that touch time. I kind of talked through the process of using a centrifugal filter. This is what that same process looks like with the Pulse. So here we're going to do a buffer exchange with the system. On the left-hand side, that yellow tube is a protein sample at about 30 milliliters, and we have a pH of 3 buffer with a little bit of indicator dye. So what we're going to be doing is we're going to be concentrating down to some set point that was predefined by our user. We're then going to do a buffer exchange to 99% efficiency, and then after that, we'll do another concentration of our exchanged molecule. So here's what it looks like, and this is sped up. But we're concentrating down. It's going to hit that 15 milliliter set point, and then it's going to begin the buffer exchange. You're immediately going to see a pH change happening, and this is happening at 2 milliliter increments. And you can see with very little buffer addition, we've already completely changed our pH. And so normally you'd be topping up a tube completely with buffer and doing a full dye volume. Here, because we're able to do this pseudo-continuous buffer exchange, we can get a much higher efficiency with much less buffer used. And so if we look at kind of what that looks like graphically, let's take each of these different lines represents kind of a different amount of buffer volume being added in a diafiltration. So the top line, the straight line, is just a single dilution. You're just taking your tube and you're adding 50 milliliters to it, and then you're concentrating it back down. And you can see at the end of that, we've heavily diluted our sample, but only to about 17% of our initial concentration. So we have to run that many times, usually 7 to 10 times, to fully get what people look for as a 99.9% buffer exchange. Now, with the Pulse, you're able to choose the step size. So in that last video, you saw a 2 milliliter step size, but you can have it anywhere in between. We can go all the way down to 0.5 milliliter. But the further down we go in step size, the closer we approximate this kind of perfect diafiltration curve. And when you do that, you need to use way less buffer. And benefits of that are, one, you're using way less buffer, but two, the whole process happens a lot faster. So you don't need to dilute your sample 7 times and concentrate it 7 times. You only really need to dilute it by another 20 milliliters of buffer. And that saves a lot of process time for you, for the system. And most importantly, if you have a really sensitive sample to shear, you're not recirculating it through a TFF or pushing it through a centrifuge column for hours every day. This is happening in maybe 20 minutes to an hour. So at least on my side of Formulatrix, we work in protein crystallography, and that's kind of how that side of Formulatrix got started. So this tool was built to solve this need for our crystallographers, and we kind of optimized it for that. And very quickly we realized this is not just a protein tool. This is kind of a universal tool for a lot of people. So we only launched about a year ago, but we're already seeing heavy applications in lipid nanoparticles, virus, so lentivirus, AAVs, virus-like particles, but also nucleic acids. We have customers doing DNA, RNA, ssRNA, tRNA, mRNA, and even cells is the most recent one. So we've been able to demonstrate that we can pass cells through this for pelletization, basically. So we're able to concentrate cells instead of pelletizing them and still get about 95% viability. So pretty excited to find out that this is actually maybe a much more broader product than we ever initially thought. So with that, we've kind of bolstered our membrane offerings to try to satisfy more people. So we have cutoffs all the way from 5 kDa to 300 kDa in PES. That's polyether sulfone. We do not have a modified PES offering for those that are curious. And then we've recently added regenerated cellulose to the mix. So we find typically the PES membranes are better performers. They concentrate a little faster, but some of our customers see a little bit less retention with those, with different molecules. So RC tends to work better for kind of a niche audience. But feel free to ask more about that to me later. And you might notice we do not have a 300 kilodalton offering with regenerated cellulose. So talking about the system again, it's incredibly compact. It's about the size of a sheet of paper, 8 inches tall. So this system can kind of go anywhere you go. We have customers that buy one and just carry it around their whole lab, or it's kind of cost effective enough that we have customers that just buy one for every part of their lab. We even have people that just stack them in a line, 3 to 7 across, and just process samples all day with them. The other benefit of this form factor is if you need sterility, it is an open system, but you can put it right in a sterile hood. And then it also is 4C compatible. It's a really common question to our protein users. So the system can be put in a cold room. Some people put it right in a refrigerator, but it does not have temperature control itself. So just to kind of bolster our claims, because this is a new thing that nobody's ever heard of, this is what some people have been saying so far. So it's an alternative to size exclusion chromatography, but we've successfully integrated the pulse for ADC production, and we're entirely satisfied. This is MIMABs out in the UK. The system is user-friendly, processes samples quickly, and is cost-effective. Trustworthy and effective method for concentrating VLPs. This is UNSW down in Australia. And the system is easy to use right out of the box. It performed comparatively well against our established TFF process. This is a customer actually ramping up to have that intermediate solution between low scale and industrial TFF. And I want to kind of emphasize that right out of the box thing. I know I said it earlier, but really we don't do, we offer training, but most of our customers take the pulse right out of the box, plug it in. It's like a toaster and you just press go. So really the startup can be as low as 5 minutes. And that's pretty exciting for a lot of people that don't have a lot of kind of robotic experience. But it doesn't stop there. I mean, we've only been selling this for about a year. We already have adoption from a lot of kind of the biggest customers on the market. People are all the way from early scale R&D to full scale production, and that's been really exciting for us. So let's talk about kind of availability. This is a big pain point for a lot of people in filtration. We have a customer that waited 18 months for a spin filter last year. So lead times have been a struggle for people, but at Formulatrix, we make all of our own consumables. We make all of our own systems, and we handle all of our own supply chain. So if you purchase an instrument right now, it'll be in your office in about 10 days, depending on how many people purchase. So we'll see. Maybe they'll be really successful here. But average consumable fulfillment, if you're in the US, can be as low as 2 days. It's usually 4 days. That's another thing we really pride ourselves on. If you're outside of the country, it'll be closer to 2 weeks. But we have no supply chain limit right now for any of our filtration components. Support response time is same day. So Pulse right now has 24/7 support for both applications and hardware. So we have around-the-clock PhDs on application support who can help you out with process optimization, getting your Pulse up and running, trying to get your retention higher, whatever it is you're trying to figure out. And if you do have a problem with your system, we generally can get that resolved within 3 days. And the Pulse is actually small enough that if you have a major issue, we'll just send you a brand new system. And that usually happens same day if you're in the US. So this is the MicroPULSE. And again, we're selling you less time at the centrifuge. But I'll open the field now to questions. Thank you very much. Oh, yeah, go ahead.
Let's hear more about the cell types.
Yeah, so she had a question about cell types. So right now we only have one collaborator doing cells with the Pulse. They were using a HeLa cell as a model. So it was a pretty robust cell. So we are curious to get more data on that to see kind of how viability will be with more sensitive cells. This instrument is available for sale right now. Contact your local rep for more details, and we're happy to get you set up. Thanks so much.